Question 10, part A. The first, second, and third terms of an arithmetic progression. So the important thing is to understand that this is an arithmetic progression. And the first, second, and third terms are 4k, k square, and 8k respectively, where k is a non-zero constant. Find the value of k. So first thing that we have is in this arithmetic progression A1, the first term is 4k. A2, the second term is k square, and A3, the third term is 8k respectively, where k is a non-zero constant. So now what do we need to find? The value of k. Okay, so when we have been given three equations like this, we know that to deal with the arithmetic progression, we need D, the common difference. And how do we get the common difference? We can find it by doing next term minus previous term, like any next term minus previous term, 3 minus 2 or 2 minus 1. So when we are being given three terms in some constant, in some variable form, so let's equate them, because A2 minus A1 will be equals to D, and A3 minus A2 will also be equals to D. So we can equate A2 minus A1 equals to A3 minus A2. So doing that, the difference between any two consecutive terms. So let's write it like this. 8k minus k square must be equals to k square minus 4k, because both are equals to D, the common difference. From here we can have an expression. So this will get 2k square. I'm shifting this to the other side. And then we get 8k plus 4k. That is 12k. Now, when they say it is a non-zero constant, if we are sure that something is non-zero, then we can cancel the variables on both sides. Okay, otherwise we cannot cancel. How we are supposed to do? We should be doing it like this. 8k square minus 12k equals 0. Then we will be taking k common, and it will give you 8k minus 12. So either k is equals to 0 or 8k minus 12 equals 0. In this way, you get one value equals to 0, but they have already told you that this is non-zero. So we can be cancelling that, okay, on both sides, and we will be left with k equals to 6. Sorry, okay, sorry, I took 2, here must be 2k. So in this way, it will become, this will also give you k equals to 6 and k equals to 0. But we know that k is not 0, so we can just do directly by cancelling the variable on both sides. So k is equals to 6. Okay, this is how we got the final answer. Now, let's move on to part B. We have part 2 to this part A as well. Now they say find the sum of the first 20 terms of the progression. So first 20 terms mean we are going to use the formula n over 2 2a plus n minus 1 times d. Okay, and when we have to find sum of 20 terms, so we'll be substituting 20 in that. So this will give you 20 over 2 to A. So now the thing is, we also don't have A right now because we have already had A in terms of K. So A1 will be equals to 4 times K. That means 4 times 6. So that will give you 24. So 2 times 24 plus n minus 1. So 20 minus 1 times D. And that is also, we haven't found D. So instead of doing all the working first, you must be finding the A and D. So let's do that. A is this. And A2 is going to be K square. That means 6 square, 36. So your common difference would be 36 minus 24. That is 8. Okay. Sorry, 36 minus 24 is 12. Okay, so your D is 12. N over 2, 2A plus N minus 1 times D. And D is 12. Now, 10 times 48 plus 19 times 12. Okay, so 19 times 12 is 228. Now, 10 times 228 plus 48 plus 48 gives you 276. And 10 times 276 would be 2,760. So yeah, this is your final answer for part 2 of part A, question number 10. Now let's do part B of the same question, and that is the fourth and sixth terms of a geometric progression. Now we are shifting your arithmetic progression to geometric progression. The fourth and sixth terms are given. Okay, so side by side, I'm also writing the fourth term is, and the sixth term is given to be 36 and 6 respectively. So 36 is your fourth term and 6 is your sixth term. The common ratio of the progression is positive. Another information that they have given you, that is going to be positive. Find the sum to infinity of the progression. Give your answer in the form a over root b minus c, where a, b, and c are integers. Okay, so what are we supposed to do is we need to find sum to infinity. Common ratio is going to be positive. Yeah, that's it. Okay, so this is the whole information that is given to us. Now we know the formula for sum to infinity, and that is sum to infinity is equals to a over 1 minus r. So we need a, that means your first term, and your common ratio. So let's break down this. If we are being given a4, that means we are being given ar cube equals to 36. And if sixth term is given to us, that means that they have given you ar to the power 5 equals to 6. So these are the two equations that will solve to get a and r. So dividing both of them, ar to the power 5 over AR to the power 3 equals 6 over 36. A and A will cancel, cube and cube will cancel, square is left behind. So R square is equals to 1 over 6. Now if we'll take square root on both sides, R will be equals to plus minus 1 over root 6. As R is positive, given to us in the question, so R will be equals to positive 1 over root 6. As we get R, so we must also be finding your A. So substituting this R in any of the equations to get your A. As we know, AR cube is equals to 36. So that means A times 1 over root 6 cube is equals to 36. And when we'll solve it further, obviously A over 6 to the power 3 over 2 equals to 36. A equals 36 times 6 root 3 over 2. Now, so we can break this into, like, you can do it directly with a calculator. Okay, this will give you 6 cube is 216, means 216 under the root. Okay, and 216 will give you 6 root 6 times 36. So 36 times 6 is again 216. 216 root 6 is your A. Now, what we have found so far, we have found your R to be 1 over root 6 and A to be 216 root 6. Now we can use the sum of infinity formula to get the sum to infinity. So sum to infinity is A over 1 minus R. So 216 root 6 over 1 minus 1 over root 6. And solving this all, but you don't need to break this square root and get the answer in decimals. Rather, we should stay in this same format. So we'll get it to be root 6 minus 1 over root 6. And in the numerator, we'll be getting 216 root 6. So it will give you 216 times 6, because this root 6 will be multiplied in the numerator, over root 6 minus 1. Yeah, that's it. So also we should be doing the 216 times 6, and that is 216 times 6 is, let me just shift this. Okay, 216 times 6 is 1296. So the final answer is 1296 over root 6 minus 1. So we got the answer in the same format. They said A over root B minus C. So A over root B minus C. So this is your whole working for part B. That gives you A equals to 1296, B equals to 6, and C equals to 1. So this is your sum to infinity. So that's all about your question number 10 part B. We found A and R by using these two equations that are given to us in form of A4 and A6. And then we just substituted in the values to get the required form. So that's all about question number 10. I hope you get it. Thank you.